All right, number 2. This one, a little more complicated looking. We have some e to the power of 2x, e to the 4x. But if we look at the general format of that, which one does this one look like out of our 6 antiderivatives? Inverse sign, right? Inverse sign has the square root of 1 minus something squared. Well, we know we're trying to make this look like that inverse sign. Right, we want this to be 1 over square root of 1 minus u squared du. So with this, the first step, if you look on your little yellow half sheet, first step says get the 1 in the denominator. So each one of those, if you look back, each one of these has a 1 in the denominator. So our first step in these problems is to make sure that 1 is there. Luckily for us, this one, it's already there. We don't have to do anything special for it. Number 3, we'll have to change this 5 to make it into a 1. But for now, step 1 is done for us. Step 2 on your little yellow sheet says write down what u squared equals, and then figure out what u and du are. So, like I said, our u substitution is a little bit different. Normally we just have u and du. Here, we have a u squared. And just like in the formula up here, our u squared is in this position right here. So what's our u squared for this problem? E to the 4x. But from that u squared, we can figure out the u and the du that we need. What's u going to be? E to the 2x, right? If we take the square root of this, that's the same as raising to the 1/2 power. So when we take the square root, it's like raising to the 1/2. Basically, we could take the 1/2 times the exponent. We get e to the 2x. And then what's the derivative of e to the 2x? E to the 2x times derivative of 2x, which is 2. Alright, so we know that u squared is going to take the place of e to the 4x. But the next step, step 3, says multiply accordingly to get du. So that's kind of like our normal u substitution. We need to make sure everything's in place here so that we can change things into u. So we've got our dx, we've got our e to the 2x, we're missing a 2. So we just need to multiply the inside by 2, outside by 1/2. And now we have everything we need for du. We have 1/2 times the antiderivative. All of the stuff in green here ends up becoming our 1 du. 1 on top, du at the end. And in the bottom we have square root of 1 minus u squared. So we've successfully made that integral look like the integral for the antiderivative of, or basically the inside here is the derivative of inverse sine. So the antiderivative is going to be inverse sine. So we have inverse sine of u, right? So make sure you're putting in u, not the u squared part. So inverse sine of e to the 2x plus c.